Hello all, good morning. Welcome to Unacademy. Let's crack it. Now crack GATE ESE with India's largest learning platform. Get Plus subscription and access unlimited live and recorded courses from the India's best educators. Now before going to start this, let me introduce myself. Myself Dhanashree. I completed my MSc in Mathematics from Mumbai University and also having 13 plus years of teaching experience, I mentored more than 10,000 plus students for the engineering. Now here Unacademy's learning app, you can go through it. How to install the Unacademy's learning app. What you will get in an Unacademy. So you will get in an Unacademy daily live classes, chat with your educator, engage in discussions, ask your doubts and answer polls while all the class is going on. Live test and quizzes, evaluate your preparation with our regular mock test and quizzes and get detailed analysis on your performance. Now structured courses. All our courses are structured in a line with your exam syllabus to help you the best prepare for it. Now unlimited access. One subscription gets you to access to all our live and recorded courses to watch from the comfort of any of your devices. Now iconic subscription. You will get the iconic subscription here for the personal coach. Get one-on-one guidance from the top exam experts as your personal coach. Align your preparation strategy and learning resources. Mains question and answer practice is there. Standard your mains answer writing through the regular practice with evaluation and personalized feedback. Now study tracker you will get. Participate in a study tracker plan and study booster workshops. Evaluate your progress in bi-weekly reviews with personal coach. Now you will get all benefits of Plus. All live classes from the top educators, mock test and quizzes, structured batch course in a line with exam syllabus. Now Plus subscription. In the Plus subscription, you will get daily live classes, chat with your educator, engage in discussions, ask your doubts and answer polls while all the class is going on. Now live test and quizzes, evaluate your preparation with your regular mock test and quizzes and get detailed analysis on your performance. Now structured courses, all our courses are structured in a line with your exam syllabus to help you the best prepare for it. Now unlimited access you will get. One subscription gets you to access all our live and recorded courses to watch from the comfort of your any of your devices. Now learn with the top educators. These are some top educators of an Unacademy. Now these are some top educators of an Unacademy. With the help of these educators, you can do your study and take your study to the next level. Now here GATE ESE. You will see many branches are available here for GATE ESE. So for each and every branch of GATE ESE, you will get different courses. Now GATE ESE. So you will get Plus subscription plan. In this Plus subscription, you will get India's best educators, interactive live classes, structured courses and PDFs, live test and quizzes. You will get in an iconic subscription. You will get all the benefits of Plus here, and you can see here personal coach. The most important benefit of here is personal coach, personalized test analysis, study planner, preparatory study material. You will get. Now Plus plan. For the Plus plan, you will see here. If you go for the 1 month subscription plan, it will cost you 5,500. But if you go for the 12-month subscription plan, it will cost you 30,250. And most important benefit is if you use my promo code DSP, you will get a 10% discount on your subscription fees. The same plan it will cost you for 27,225. Now iconic subscription. For the iconic subscription, 12 months plan is 50,250. The same plan it will cost you for 45,225 if you use my promo code DSP. Now, evolve for the GATE 2022 for the civil engineering batch C here. So the batch C is already started from 25th of January 2021. To involve in this batch, you can use my promo code DSP to get the 10% discount. Now, ascend for the GATE 2023 for batch C is already started from the 25th of January for civil engineering. Now, to evolve in this batch or to take up enroll in this batch, you can use my promo code DSP to get the 10% discount. Now batch A here, new batch alert for you. Now evolve for the GATE 2022 for the chemical engineering. So you will see here, start the date here 25th of January from 2021. Now the same batch will be already started from the 25th of January, and to enroll in this batch you can use my promo code DSP. Now batch C is already started here. So ascend for the GATE 2023 for the mechanical engineering, the new batch alert here. The batch is already started from 25th of January 2021. Now to evolve in this batch, you can use my promo code DSP to get the 10% discount on it. Now spark for the GATE 2022 for the civil engineering batch A. So this batch will be starting from 22nd of February 2021. To evolve in this batch or to enroll in this batch, you can use my promo code DSP to get the 10% discount. And this 10% discount is only valid for the limited period. So as early as possible, you can enroll your name in these batches. Now ascend for the GATE 2023 Mechanical Engineering Batch E will be started from 22nd of February 2021. To evolve in this batch, you can use my promo code DSP. To evolve for the GATE 2022 Batch E, that will be starting from 22nd of February 2021. To evolve in this batch, you can use my promo code DSP to get the 10% discount. Now mission DDR here for GATE 2022. So starting from the 22nd of February 2021, and here to enroll in this batch, you can use my promo code DSP to get the 10% discount. Now let's start our actual topic here, complex numbers. So what you mean by complex number and how it is represented, okay, and what you mean by Argand diagram, that we will see in detail in this. The number of the form z is equal to x plus iy. You know that the number of the form z is equal to x plus iy, where x and y are real. X and y are real numbers, and it is imaginary unit fundamental property that here I square is equal to minus 1. That is I is equal to root of minus 1, right? Is called the complex number. Now for example, here 2 plus 3i, 2 minus 3i, 4 plus 3i, okay, 1 by 2 plus 3i, or 1 by 2 minus 1 by 2 minus 4i. It's the complex number. It is a representation of a complex number. So here x is called as the real part and y is called the imaginary part, right? So of the complex number. Now it means if two complex number are equals, if it means their real parts and imaginary parts are equal. Okay. Now conjugate of the complex number. What do you mean by conjugate of a complex number? Conjugate of a complex number. Here z is equal to x plus iy. Then is z is equal to x minus iy is the conjugate of z. Right? If z is equal to x plus iy is the complex number, then z is equal to x minus iy is the conjugate of z. Right? Now, we will see Argand diagram. What do you mean by Argand diagram? Okay. Here Argand diagram. Geometrical representation of a complex number. You can see geometrical representation of a complex number. Geometrical representation of a complex number z is equal to x plus iy in a plane given by the scientist J.R. Argand. It is known as Argand diagram. Okay. It is known as Argand diagram. It is known as Argand diagram. Okay. Now consider a line of length A. Now see, consider a line of length A. How to represent it? Consider a line of length A where OA is equal to A. Rotate OA. Now see. Now this rotate OA with an by 180 degree. Now see, rotate this OA by 180 degree and in an anti-clockwise direction, which gives you minus A, right? Rotate OA in an anti-clockwise direction with 180 degree, it will gives you minus A. So when we this process we can write 0 into 180 degree gives A is equal to minus A, right? Now again 2 times if you rotate 0 into A is equal to A and 1 into 180 degree gives you minus A. Gives minus 1 into A is equal to minus A, right? Now, exactly similar way, if we rotate this A 3 times, so what you will get? If you rotate this 180 degree gives you minus 1 raised to 2 into A, which is equal to A. Right? Now rotate this 180 degree 3 times gives you minus 1 raised to 3 into A, that is minus A. Now if we rotate it by, now after 180 degree, if we rotate it by 90 degree, okay, if we rotate this by 90 degree, so what you will gives you? If we rotate this by 90 degree, half of it, right? So half of 180 degree, we can write here. If we rotate by 90 degree, if we rotate it by 90 degree, so what will becomes here? Half of 180 degree, which is equal to, now we know that 1 into 180 degree is equal to minus A. So half of 180 degree you will get minus 1 raised to 1 by 2 into A. So is it nothing but root of minus 1 into A? And root of minus 1 we know that it is I. So how the scientist Argand represented the imaginary part in a plane. So here rotate 0A into minus this 90 degree. So it will gives you the minus A. Right? Hence this is the geometrical meaning of IA is rotated A by 90 degree. What you mean by AI? So IA or AI means rotating A by 90 degree. Rotating A by 90 degree. Right? So this represents a Argand diagram. Right? Argand diagram, it means complex number we can represent it by using this. So if we represent 0, 180 degree in an anti-clockwise direction, it will gives you AC. Now, if we rotate 1 times 180 degree, it means from here to here. Now this OA, it means 1. OA, it means A here, right? The same OA, it will gives you after rotating 180 degrees minus A. If we rotate this 180 degree 2 times, it means again here to here, right? 1 time and second time. Then this rotate, after rotating this, you will get minus 1 into square, that is into A is equal to again A, it will gives you. If we rotate A 3 times, so 1 times already done, 2 times already done, now 3 times. So you will get minus 1 raised to 3 into A, that is minus A. Clear? So in this way, but we know that if the same A, if we rotate by 90 degree, instead of 180 degree, if we rotate it by 90 degree. So what will happen? It is 180 by half. Right, 90 it means 180 by half. So if we rotate this by halfway, so minus 1 raised to 1 by 2, right? So half of it. So into a, but 1 minus 1 raised to 1 by 2 is nothing but root of minus 1, and root of minus 1 is I, as we have seen the definition of a complex number, right? So ai means rotating a by 90 degree. So this representation is known as a Argand diagram. It means representing a complex number in a plane. It is known as a Argand diagram. Okay. Now, polar form of the complex number. Next point we will see polar form of the complex number. Polar form of a complex number. Right? So cos theta is equal to, what is your cos theta? Now we can draw it on a plane. Suppose this is your R, this is your Y, here is X, this is R, this is theta. Right? Now, this is X plane, this is Y plane. Here is origin. Now what do you mean by cos theta? By our definition, cos theta is equal to what? Opposite side, here adjacent side upon hypotenuse, right? So what is adjacent side? Adjacent side is x. So adjacent side upon hypotenuse, we can write here x upon r is the hypotenuse, right? So here x upon r. So what is sine theta? Sine theta is opposite side upon hypotenuse. So sine theta is y upon r, right? So you will get here x is equal to r cos theta, y is equal to r sin theta, right? Now polar equivalent form. So you will get z is equal to, we know that x plus iy. So x is r cos theta plus I into r sin theta. So we can take r common. So r into bracket, you will get cos theta plus I sin theta, right? And where r square is equal to, take the r square. So you will get x square r square cos square theta, y square r square sin square theta. So take r square common, cos square theta plus sin square theta. So which is equal to x square plus y square, right? And tan theta is equal to what? Sin theta upon cos theta. So you will get y upon x, right? Now we will find out the modulus of the complex number. Modulus of complex number, right? So what is your modulus of complex number? Z is equal to x plus iy, represented as r is equal to mod of x plus iy, which is equal to square root of x square plus y square. Now, your amplitude or argument of a complex number. Amplitude or argument of the complex number. Of the complex number. So what you will get? Tan theta is equal to y by x. So which implies theta is equal to tan inverse of y by x. Right? No. No, what is addition or subtraction of a complex number? Addition and subtraction of complex number. So here z1 is equal to x1 plus iy1. z2 is equal to x2 plus iy2. So z1 plus z2 is equal to x1 plus x2 plus I into y1 plus y2. So what is z? z1 plus z2, this is real part, this is imaginary part. Okay. Now product of complex number. Product of complex number. Okay. So you get product of complex number. z1 is equal to x1 plus iy1. z2 is equal to x2 plus iy2 are the complex number. Then z1 into z2. x1 plus iy1 into x2 plus iy2, right? So we'll get x1 x2 plus x1 y2, x1 x2 plus x1 y2 I plus x2 y1 I minus y1 y2, or minus y1 y2. So we will get, now z is equal to x plus iy, which is equal to r into bracket cos theta plus I sin theta, such that z is equal to z1 plus z2. Therefore z is equal to r into bracket cos theta plus I sin theta, which is equal to r1 r2 into bracket cos of theta 1 plus theta 2 plus I into sin of theta 1 plus theta 2, right? So we will get r is equal to r1 into r2 and theta is equal to theta 1 into theta 2, theta 1 plus theta 2. R is equal to r1 into r2, theta is equal to theta 1 plus theta 2. Okay. Now we will see exponential form of a complex number. Okay. Exponential form of a complex number. Exponential form of a complex numbers. Okay. So here we know that sin x is equal to sin x expansion x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial plus x raised to 9 by 9 factorial. Call this as equation number 1. What do you mean by cos x? Cos x is 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus and so on, right? So we'll get e raised to x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial plus and so on. E raised to ix you will get here. So e raised to ix is equal to 1 plus, instead of x represent x by ix. So plus I into x bracket square upon 2 factorial plus I into x bracket cube upon 3 factorial plus x raised to I x raised to 4 upon 4 factorial plus and so on, right? So how we can represent this? E raised to ix is equal to, we can write 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus I into x minus x cube by 3 factorial plus x raised to 5 by 5 factorial plus and so on, minus and so on, right? So take it here, 1 minus, so is it nothing but cos x? So e raised to ix is equal to cos x plus I sin x. E raised to ix is cos x plus I sin x, and e raised to minus ix is equal to cos x minus I sin x, right? So z is equal to x plus iy is a complex number. Then z is equal to x plus iy is equal to r into cos theta plus I sin theta, r into cos theta plus I sin theta is equal to r e raised to I theta, right? Equal to r e raised to I theta. This is known as exponential form of a complex number. Z is equal to r e raised to I theta is known as exponential form of a complex number. exponential form of a complex number. Okay. Now we will see here modulus of OA. If z is equal to x plus iy, this is very important formula. X plus z is equal to x plus iy, then theta is equal to tan inverse of y by x, mod of y by x. First quadrant, right? Second one, z is equal to minus x plus iy, then theta is equal to pi minus tan inverse of y by x, mod of y by x, second quadrant. Third one, z is equal to minus x minus iy, then theta is equal to what? Pi plus tan inverse of mod of y by x, third quadrant, right? Now fourth one we'll see. Here fourth one, if z is equal to x minus iy, if z is equal to x minus iy, then theta is equal to minus of tan inverse of y by x, mod of y by x. Okay, then it lies in fourth quadrant. Okay. Now let's see. The arguments are given, then we have to find out the z. Okay, so let's see first example. Argument of z minus 1 is equal to pi by 2 and argument of z minus I is equal to 0. Then find z. First example, then find z, right? So let z is equal to what? X plus iy. We know that. So it is given. Argument of z minus 1 is given. So z minus 1 is equal to what? X minus 1 plus iy. Right? So z minus I. What is z minus I? X plus y minus 1i. Right? Now, an argument of here argument of z minus 1. It means what? Argument of z minus 1 means what? Z is x plus iy. So here argument of x, tan inverse of y upon x, but here x is equal to x minus 1. So tan inverse of y upon x minus 1, right? Argument of, so tan y upon x minus 1 is equal to pi by 2. Tan inverse of pi by, tan of pi by 2. Tan of pi by 2 is infinity. Okay. So this implies x minus 1 is equal to 0, which implies x is equal to 1. Right? X minus 1 is equal to 0, which implies x is equal to 1. Now argument, second thing is given, argument of z minus I is equal to 0. That is, z it means what? X plus iy minus I is equal to 0. So tan inverse of here y upon, so y it means y minus 1 upon x, okay, is equal to 0. So which implies tan inverse of y minus 1 upon x is equal to tan inverse of 0. So y minus 1 upon x is equal to tan inverse of 0 is 0. So y minus 1 is equal to 0, which implies y is equal to 1. So now we got the value of x and y. So what will be your z? Z is equal to x plus iy, it means 1 plus I. Yeah, so that is your 1 is z is equal to 1 plus I. Now if you find out the argument of this z, you will get the same. Argument of this, so you will get the same. Okay. Now let's move for the next example. See, if z plus I upon z plus 2, if z plus I upon z plus 2 is purely imaginary, is purely imaginary. Show that the locus of xy is a circle of radius root 5 by 2. Okay, show that the locus of a xy is a circle of radius root 5 by 2. Now consider here, see, consider z is equal to x plus iy. So we are giving z plus I upon z plus 2 is purely imaginary. It means what? Real part is 0. Right? What it indicates, it is purely imaginary. It means real part of this is 0. Right? So we will calculate first z plus I upon z plus 2. So z is equal to what? X plus iy plus I upon x plus iy plus 2, which is equal to x plus I into y plus 1 upon x plus 2 plus iy. Right? So z plus I, which is equal to x plus I into y plus 1 into bracket x plus 2 in minus iy upon x plus 2 bracket square plus y square. Right? So z plus I upon z plus 2 is equal to here x plus 2, x into x plus 2 plus y into y plus 1 plus I into y plus 1 into x plus 2 minus xy upon x plus 2 bracket square plus y square. Since z plus I upon z plus 2 is purely imaginary, since z plus I upon z plus 2 is purely imaginary. Okay? So that is real part is 0. Therefore, real part of z plus I upon z plus 2 is equal to 0. As real part is 0, what is the real part of here? So you will get real part is x into x plus 2 plus y into y plus 1 upon x plus 2 bracket square plus y square, which is equal to 0, which implies x into x plus 2 plus y into y plus 1 is equal to 0. Therefore, x square plus 2x plus y square plus y is equal to 0. That is x square plus y square plus 2x plus y is equal to 0. Now this is a circle, equation of a circle, general equation of a circle. So you will get which is a circle having center at -1 by 2 and radius root 5 by 2. Right? So hence locus of xy is a circle. Hence locus of xy is a circle of radius root 5 by 2. Hence it is proved. Right? This is a circle radius root 5 by 2. Now we will see, find the principal amplitude of a complex number. Find the principal amplitude. Find the principal amplitude of complex number z minus 1 upon z plus 1 if the amplitude is pi by 4. Show that x square plus y square minus 2y is equal to 1. Okay, so now it is given that z is equal to x plus iy. So z minus 1 upon z plus 1, which is equal to, now take x plus iy minus 1 upon x plus iy plus 1. Now take the real part. X minus 1 is the real part, plus iy upon x plus 1 plus iy. Right? So take the x minus 1 upon iy, x plus, so take the, we are rationalizing, we will get x minus 1 plus iy into x plus 1 minus iy upon x minus 1 second, x plus 1 iy into x plus 1 minus iy. Right? So we will get here x minus 1 into x plus 1 plus y square plus I into y into x plus 1 minus y into x minus 1 upon here x plus 1 bracket square plus y square. So z minus 1 upon z plus 1 is equal to x square minus 1 plus y square plus I into xy plus y minus xy plus y upon x plus 1 bracket square plus y square. Right? So x z minus 1 upon z plus 1 is equal to, we get 2y upon x plus 1 bracket square plus y square. Right? So theta is the amplitude. If theta is the amplitude, theta is equal to tan inverse of 2y upon x plus 1 bracket square plus y square upon x square plus y square minus 1 upon x plus 1 bracket square plus y square. Right? So therefore, we get theta is equal to tan inverse of 2y upon x square plus y square minus 1, where minus pi is less than or equal to theta is less than or equal to pi. Call this as equation number 1. If theta is equal to pi by 4, that is amplitude is pi by 4, amplitude is pi by 4, therefore pi by 4 is equal to tan inverse of 2y upon x square plus y square minus 1. So tan pi by 4 is equal to 2y upon x square plus y square minus 1. So which implies x square plus y square minus 1 is equal to 2y. So x square plus y square minus 2y is equal to 1. Hence proved. Okay, hence it is proved. Now we will find out the locus. Find the locus. Find the locus and represented by, find the locus represented by, find the locus represented by mod of z plus 1 minus I is equal to 2. We know that if z is equal to x plus iy, then mod z is equal to root of x square plus y square. So given mod of z plus 1 minus I is equal to 2. So x plus iy plus 1 minus I is equal to 2. Right? So therefore, we'll get mod of x plus 1 plus I into y minus 1 is equal to 2. So root of x plus 1 bracket square plus y minus 1 bracket square is equal to 2. So therefore x plus 1 bracket square plus y minus 1 bracket square is equal to 4. So which is a circle having center at minus 1 1 and radius 2. And radius 2. Hence the locus of a circle is locus of z plus 1 minus I is a circle with radius 2. With radius, okay. Let's see the next question. Find the complex number z. Find the complex number z if amplitude of z plus 2I is equal to pi by 4 and amplitude of z minus 2I is equal to 3 pi by 4. So consider here z is equal to x plus iy. So amplitude of z plus 2I is equal to pi by 4 and amplitude of z minus 2I is equal to 3 pi by 4. Right? So z plus 2I is equal to x plus iy plus 2I, which is equal to x plus I into y plus 2. Z minus 2I is equal to x plus iy minus 2I, which is equal to x plus I into y minus 2. Right? So we will get amplitude of z plus 2I is equal to x plus iy. So amplitude of z plus 2I is given. Right? So we can write amplitude of z plus 2I is equal to pi by 4 and amplitude of z minus 2I is equal to 3 pi by 4. So here is tan inverse of y plus 2 upon x is equal to pi by 4 and tan inverse of y by 2 minus x is equal to 3 pi by 4. So y plus 2 by x is equal to tan pi by 4. Y minus 2 by x is equal to tan 3 pi by 4. So y plus 2 by x is equal to 1 and y minus 2 by x is equal to minus 1. Right? So just find out y plus 2 is equal to x. Y minus 2 is equal to minus x. So x minus y is equal to 2 and x plus y is equal to 2. So solving these two equations, you will get 2x is equal to 4. So x is equal to 2. X is equal to 2, put here, and y is equal to 0. Right? So complex number z is equal to x plus iy, which is equal to 2 plus 0, I 0. So which implies z is equal to 2. It's very simple to find out the complex number when the argument is given. Okay. Now let's you know how to find out the locus and yeah, no. Let's see. Show that the points -1 1 3 plus 4i comma 1 upon 3 plus 4i on on Argand diagram lie on a circle. Find the center and radius of a circle. Find the center and radius of circle. Okay. If -1 1 are the points on the circle, then center of the circle must be lie on y-axis, right? So right, if -1 and 1 are the points on the circle, then center of the circle must lie on y-axis, right? Equidistance from y-axis. Now equation of the circle is what we will get. Suppose 0b is the center of the radius. Suppose 0b is a center. Suppose 0b is a center of a circle and radius is r. Therefore equation of the circle is x square plus y minus b bracket square is equal to r square. Since 1 minus 1 and 3 plus 4i, are the points on the circle, so point 1 0 gives 1 plus 0 minus b bracket square is equal to r square, which implies 1 plus b square is equal to r square, right? So you get 9 plus 4 minus b bracket square is equal to r square. So 0.34 gives 9 plus 16 minus 8b plus b square is equal to r square. So 25 minus 8b plus b square is equal to r square, right? Now this is equation 1, this is equation number 2. So from equation 1 and 2 we give 1 plus b square is equal to 25 minus 8b plus b square. Again b square cancel out. We'll get 8b is equal to 24, which implies b is equal to 3. Right? Once you get from this equation 1, we'll get from equation 1, we get 1 plus 9 is equal to r square, which implies r square is equal to 10, r is equal to root 10. Right? Now equation of the circle is equation of the circle is x square plus y minus 3 bracket square is equal to 10. Okay, so we have to show that 1 upon 3 plus 4i satisfies the equation of the circle. Satisfies equation of a circle. Right? So that is 1 upon 3 plus 4i. Now rationalizing it into 3 minus 4i upon 3 minus 4i. So we get 3 minus 4i upon a square, that is 9 plus 16. 3 upon 25 minus 4i upon 25. Right? So we'll get, that is 3 by 25 bracket square plus minus 4 by 25 minus 3 bracket square is equal to 3 by 25 bracket square minus 79 by 25 bracket square. So after adding this, you will get 6250 upon 620, which is equal to 10. Hence equation of the circle 1 upon 3 plus 4i satisfies the equation of a circle. Clear? Let's read next example. A square lies, see, a square lies above real axis in Argand diagram and two of adjacent vertices and two of its adjacent vertices are the origin and the point 2 plus 3i and the point 2 plus 3i. Find a complex number representing the two vertices. Okay, find the complex number. Find the complex numbers representing other two vertices. Okay. The square lies on the Argand diagrams. See, the square lies above. The square lies above real axis in an Argand diagram. Above real axis in Argand diagram. Right? In Argand diagram. Now see here, two vertices are origin O and point. Therefore, the two vertices are origin O and point A of 2 plus 3i is as shown in the figure. Is as shown in the figure. Is as shown in the figure. So we require square. So it looks like a square. A of 2 plus 3i. There is B, y-axis. There is x-axis. There is 0, 0 is the point C. Yeah. So we'll get A, B, C, O. No, here OA bar, therefore OA bar is equal to 2 plus 3i. So OC bar is equal to OA bar into cos pi by 2 plus I sin pi by 2. 90 degree, we are rotating this OA bar by 90 degree. So cos pi by 2 plus I sin pi by 2. So OA bar is 2 plus 3i. Right? Cos pi by 2 is 0. Sin pi by 2 is 1. So here is I. So you will get here 2i minus 3 because 3i square is minus 1. So 2i minus 3. So OC bar is equal to what? OC bar is equal to 2i minus 3. Right? 2i minus 3. Now, this is your OC bar. So what is AO bar? Therefore, AO bar is equal to minus OA bar, which is equal to minus of 2 plus 3i. Okay, AO bar is equal to what? Minus 2 minus 3i. AB bar is equal to AO bar into cos pi by 2 minus I sin pi by 2, which is equal to minus 2 minus 3i into 0 minus I, which is equal to 2i minus 3. So AB bar is equal to minus 3 plus 2i. OB bar is equal to OA bar plus AB bar, which is equal to 2 plus 3i plus minus 3 plus 2i, which is equal to minus 1 plus 5i. So OB bar is equal to minus 1 plus 5i. Okay. The other vertices of the square are minus 1 plus 5i and minus 3 plus 2i. Clear? Let's see. Your De Morgan's theorem. Okay. We'll see De Morgan's theorem. De Morgan's theorem. Now, let's see. For any statement, what is the statement of this theorem? Statement will get for any real number n, for any real number n, cos theta plus I sin theta bracket raised to n is equal to cos n theta plus I sin n theta. Right? This is now. If e raised to I theta is equal to cos theta plus I sin theta, e raised to I theta is equal to cos theta plus I sin theta, e raised to minus I theta is equal to cos theta minus I sin theta. Right? Third one, cos theta 1 plus I sin theta 1, cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2 is equal to, can we write here is same, is equal to cos theta of theta 1 plus theta 2 plus I sin theta 1 plus theta 2. Cos theta 1 plus theta 2 plus I into sin theta 1 plus theta 2 plus I sin theta 1 plus theta 2. Okay. Now let's see. Here cos theta, fourth one, cos theta 1 plus I sin theta 1 upon cos theta 2 plus I sin theta 2 is equal to, we can write cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. So fifth one, 1 upon I is equal to minus 1. Sixth one, 1 upon a plus ib is equal to a minus ib upon a square plus b square. Seventh one, if x plus iy is equal to r into cos theta plus I sin theta, then x minus iy is equal to r into cos theta minus I sin theta. Okay, so we will use the De Moivre's theorem to prove some results. Okay, so let's see. First example on this. If 2 cos alpha, if 2 cos alpha is equal to x plus 1 upon x, 2 cos beta y plus 1 upon y, 2 cos gamma is equal to z plus 1 upon z, prove that xyz plus 1 upon xyz is equal to 2 cos of alpha plus beta plus gamma. Okay, now we have to prove this. Now let 2 cos alpha is equal to x plus, so we can write here 2 cos alpha is equal to 3x square plus 1. We can write 2 cos alpha into x is equal to x square plus 1. So x square minus 2 cos alpha into x minus plus 1 is equal to 0, which is quadratic equation in x. So we can find out the value of x is here. So x is equal to minus of b, that is minus of minus plus 2 cos alpha plus or minus square root of b square, that is 4 cos square alpha minus 4 upon 2. So which is equal to 2 cos alpha plus or minus 2 into cos square alpha minus 1 upon 2. So which is equal to cos alpha plus or minus root of minus of 1 minus cos square alpha. So which is equal to upon 2. Right? So which is equal to cos alpha plus I plus or minus I sin alpha upon cos alpha one minus cos square minus of sin. Okay. Cos alpha plus I sin alpha is upon 2 I sin square alpha, I into root of sin square alpha. Correct. Now, can I write this as x is equal to, that is x is equal to cos alpha plus or minus cos alpha plus or minus I sin alpha, cos alpha plus or minus I sin alpha, x is equal to cos alpha plus I sin alpha, y is equal to cos beta plus I sin beta, and z is equal to cos gamma plus I sin gamma. XYZ is equal to cos alpha plus I sin alpha into cos beta plus I sin beta into cos gamma plus I sin gamma. Okay. So XYZ is equal to, we will get Let's see. xyz is equal to cos alpha plus I sin alpha, cos beta plus I sin beta into cos alpha gamma plus I sin gamma. All this is equation number 1. Now xyz is equal to cos of alpha plus beta plus gamma plus I into sin of alpha plus beta plus gamma. So 1 upon xyz is equal to 1 upon cos of alpha plus beta plus gamma plus I sin alpha plus beta plus gamma. So 1 upon xyz is equal to cos of alpha plus beta plus gamma by using De Moivre's theorem. Cos 1 upon cos theta plus I sin theta, it means cos theta minus I sin theta plus gamma. Call this as equation number 2. Right? This is your equation 1 and 2. We'll get, adding equation 1 and 2, we'll get x into yz plus 1 upon xyz is equal to 2 cos of alpha plus beta plus gamma. Right? 2 cos of alpha plus beta plus gamma. Now let's see. No. So simple example. We can prove these examples. So prove that. Here prove that cos theta plus I sin theta bracket raised to m upon sin phi plus I cos phi bracket raised to n is equal to minus I raised to n into cos of m theta plus n phi plus I sin m theta plus n phi. Right? So cos theta plus I sin n theta bracket raised to m upon sin phi plus I cos phi bracket raised to n is equal to cos theta plus I sin theta bracket raised to m upon I into cos phi minus I sin phi bracket raised to m. So we'll get cos theta plus I sin theta bracket raised to m upon I raised to n into cos phi minus I sin phi bracket raised to n, which is equal to minus I raised to n into e raised to I theta bracket raised to m upon e raised to minus I phi bracket raised to n. So cos theta plus I sin theta bracket raised to m upon sin phi plus I cos phi bracket raised to n is equal to minus I raised to n into e raised to I m theta upon e raised to minus I n theta, which is equal to minus I raised to n into e raised to I n theta plus I n theta, I n phi, sorry, plus I n phi, which is equal to minus I raised to n n theta plus n phi. Plus n phi. Okay. And the next question, solve by De Moivre's theorem. X raised to 5 minus 1 plus I is equal to 0. Right? So let 1 plus I is equal to R into bracket cos theta plus I sin theta. So here R is equal to root of 1 plus 1, which is equal to root 2, and theta is equal to tan inverse of 1 by 1, which is equal to pi by 4. So therefore 1 plus I is equal to root 2 into cos pi by 4 plus I sin pi by 4. So 1 plus I is equal to root 2 into cos of 2 pi m plus pi by 4 plus I sin 2 pi m plus pi by 4. Right? So you will get 1 plus I bracket raised to 1 by 5. So by De Moivre's theorem, here root 2 cos of 2 pi m plus pi by 4 plus I sin 2 pi m plus pi by 4 bracket raised to 1 by 5, which is equal to root 2 raised to 1 by 5 into cos of 8 pi m plus pi upon 4 plus I sin 8 pi m plus pi upon 4 bracket raised to 1 by 5. So by De Moivre's theorem, 1 plus I bracket raised to 1 by 5 is equal to 2 raised to 1 by 10 into bracket cos of 8 pi m plus pi upon 20 plus I sin 8 pi m plus pi upon 20, where m is equal to 0, 1, 2, 3, 4 and so on. Hence, all values of 1 plus I bracket raised to 1 by 5 are x0 is equal to 2 raised to 1 by 10 cos of pi by 20 plus I sin pi by 4 if m is equal to 0. x1 is equal to 2 raised to 1 by 10 cos of n pi by 20 plus I sin n pi by 20 if m is equal to 1. x2 is equal to 2 raised to 1 by 10 cos of 17 pi by 20 plus I sin 17 pi by 20 if m is equal to 2. Right? x3 is 2 raised to 1 by 10 cos of 25 pi upon 20 plus I sin 25 pi upon 20 if m is equal to 3. Right? And x4 is equal to 2 raised to 1 by 10 into cos of 33 pi upon 20 plus I sin 33 pi upon 20. Right? So continuing in this product, hence their product continue to, hence their product x0 into x1 into x2 into x3 into x4 is equal to 2 raised to 1 by 2 into bracket cos of 17 pi by 4 plus I sin 17 pi by 4, which is equal to 2 raised to 1 by 2 into cos of 4 pi plus pi by 4 plus I sin 4 pi plus pi by 4, which is equal to 2 raised to 1 by 2 into cos of pi by 4 plus I sin pi by 4. which is equal to 2 raised to 1 by 2 into bracket 1 by root 2 plus I 1 by root 2. I hope you are getting it clearly, right? So x0 into x1 into x2, we will get x0 into x1 into x2 and so on up to x4, we will get 1 plus I. Hence the continued product, all the values of 1 plus I bracket raised to 1 by 5 is 1 plus I. Okay. So see, I hope you are getting it clearly how to find out the or how to apply the De Moivre's theorem as well as Argand diagrams. Okay. If you are liking my videos, please do like, share and subscribe, and don't forget to press the bell icon for the further notification.